Solve the equation by expressing each side as a power of the same base, then equating exponents. So again, what we're trying to do here is express each having the same base. And there's a couple different ways to do it. In this case, I'm going to keep them both in base 4. So the first is 4 raised to the 3x plus 5 equals 1 over 256. Well, I can express 256 as base 4, and that would be 1 over 4 to the 4th power. Now, I don't have them in the exact same base because 4 to the 4th is in the denominator, so I'm going to use the negative exponent rule to change so that they are expressed in the same base. So then I'd have 4 raised to the 3x plus 5 equaling 4 raised to the negative 4th power. Since my bases are the same, they're both 4, I equate the exponent. So I set 3x plus 5 equal to negative 4, and then I just solve my linear equation. So 3x would equal negative 9, and then dividing by 3, x would equal a negative 3. Next example, I have 2 raised to the 3x plus 7 equals 1/4. So I'm going to express them both in base 2. So the first doesn't need any change. I'm going to leave that as 2 raised to the 3x plus 7. And 4 I can rewrite in base 2 as 2 squared. But again, these both aren't base 2 in their current form. So what I need to do is apply my negative exponent rule. So this would be 2 raised to the 3x plus 7 equals 2 to the negative 2nd power. Next, I'm going to set my exponents equal to one another. So 3x plus 7 would equal negative 2. And then subtract 7 from both sides. 3x would equal negative 9 and divide by 3. So again, x would equal negative 3. Next, we're going to solve logarithmic equations. So we need to also be sure that our answer fits within the domain. So for this, remember to find your domain, we would set our argument, that's x plus 3, to be greater than 0. So we know when we solve subtracting 3 from both sides, our answer has to be greater than negative 3. So step number 1 is to condense so that we're dealing with a single logarithm. This is already condensed. Next, we're going to change it from logarithmic form to exponential form. So remember, 4 is the base, 3 is the exponent. So we have x plus 3 equals the base 4 raised to the exponent of 3. So that gives us x plus 3 equals 4 to the 3rd power, which is 64. And then we're going to subtract 3 from both sides. So x would equal 61. We need to make sure 61 fits within our domain, and 61 is indeed greater than negative 3. Our next problem, remember our first step is to condense, so we're rewriting this as a single logarithm. So here we have log base 4 of x plus 5 plus log base 4 of x minus 1. So we are going to use the product rule since we're adding two logs together. So this is going to be log base 4 of x plus 5 times x minus 1 equals 2. Next, we can go ahead and expand or use our distributive property to multiply these together. So we'd have log base 4, and I'm going to do this to the right. X plus 5 times x minus 1 would be x squared minus 1x plus 5x minus 5 using the distributive property or the FOIL method. When I combine like terms, it gives me x squared plus 4x minus 5. So my argument is x squared plus 4x minus 5 would equal 2. Next, I'm going to change it from logarithmic form to exponential form. So I set my argument, x squared plus 4x minus 5 equaling my base, which is 4, raised to my power, which is 2. So that gives me x squared plus 4x minus 5 equals 16. Since I have a quadratic, I need to set this to 0. So you're going to subtract 16 from both sides. That gives you x squared plus 4x minus 21 equals 0. Now you're going to use your shortcut in factoring. Remember, we're going to look at the factors of negative 21 that add to a positive 4. So that's going to be a positive 7 and a negative 3. So next, I set each factor to 0 to solve. So I have x plus 7 equals 0 and x minus 3 equals 0. So one possible answer is x equals negative 7. The other possible answer is x equals 3. So keep in mind you need to check to make sure that your answer doesn't make either one of your arguments less than or equal to 0. So when I plug negative 7 into either my original or my second step, notice what happens. Here I have the log base 4 of x plus 5 as my first term. Notice when I plug negative 7 in for x, I would have log base 4 of negative 7 plus 5, and that would give me a negative argument. Can't have a negative argument. Remember, this value has to be greater than 0, so negative 7 cannot be a solution. You would check it with both, but since it didn't work on the first, that's all you need to reject that. Okay, so when we look at our positive 3, so again, we have log base 4 of x plus 5 plus log base 4 of x minus 1. If I plug 3 in for x in either place, this becomes log base 4 of positive 8 plus log base 4 of positive 2. Since my arguments are both positive, then x equals 3 is an acceptable answer and would be the only correct answer for this particular equation. So please, please make sure you check. Next, we're going to solve an exponential equation. And we're going to express the solution set in terms of natural logs. So in the first problems we did, we could express them both as having the same base. But in this case, we can't change 2 into base 5 or 5 into base 2. So what we're going to do is apply the natural log to both sides. So we'd have the natural log of 2 raised to the x plus 6 equals the natural log of 5. Now we're going to apply the power rule. So remember, when we have an exponent, in this case x plus 6, it's going to move in front of our log. So this becomes x plus 6 times the natural log of 2 equals the natural log of 5. I want x to be by itself, so I need to get rid of the factor the natural log of 2. So I'm going to divide both sides by the natural log of 2. So this gives me x plus 6 equals the natural log of 5 over the natural log of 2. I'm going to subtract 6 from both sides. So this gives me x equals the natural log of 5 over the natural log of 2 minus 6. Next, again, we're going to solve an exponential equation where the bases cannot be made the same. So the first thing that we're going to do is to apply the natural log to both sides. Let's take one step back for a second. So let's look at natural log and what it means, and then we're going to solve this in a second. So the natural log is the same thing as log base e. Keep in mind again that whenever we raise a logarithm has an argument with the same base, then our answer is simply the exponent itself. So again, anytime we have a logarithm where the argument has a base as the same as the base of the log, then our answer is simply the exponent. One more time. So again, if we have a log whose base is the same thing as the base of the argument, then our answer is simply the exponent. So two things to keep in mind. First of all, the natural log is the same thing as log base e. Secondly, if our base of the log is the same as the base of our argument, then the answer is simply the exponent. So in this case, when we take the natural log of both sides, keep in mind again, you don't have to do this, but I'm going to do it for explanation purposes, that the base of the logarithm is the same as the base of the argument. Therefore, my answer to the left-hand side is simply the exponent, x plus 7, and that would equal the natural log of 3. Our last step would be to subtract 7 from both sides. So x would equal the natural log of 3 minus 7. Since 7 doesn't have a natural log, and even if it did, you don't subtract the 3 and the 7. Next one, the only difference in this problem is in the instructions. It says use a calculator to obtain a decimal approximation correct to 2 decimal places. So again, since we can't write 7 and 17 into the same base, we're going to apply the natural log to both sides. Next, use the power rule. So that means this x goes in front of our natural log, and that gives us x times the natural log of 7 equals the natural log of 17. Since I'm solving for x, I'm going to divide both sides by the natural log of 7. So x equals the natural log of 17 over the natural log of 7. So what you want to do is plug that into your calculator. So again, we have the natural log of 17 over the natural log of 7, and that comes out to 1.4559 So we're going to round to 2 places. So we're rounding to the hundreds place. So since this is a 5, this will change to a 6. So our answer would be 1.46. Okay, our last problem. Again, we're going to solve. We can't express them as having the same base. So the first thing that we need to do before we apply the natural log to both sides is to isolate our base e. So we're going to divide both sides by 7. So this would give us e to the x equals 12/7. Next, I'm going to apply the natural log to both sides. And again, remember when I take the natural log of base e, since the bases are the same, my answer is just the exponent. So when I take the natural log of e to the x, my answer is x. So x would equal the natural log of 12/7. So again, on your calculator, you're going to figure out what the natural log of 12/7 is. And that would be approximately 0.538996. So we're rounding to two places. So since 8 is greater than 5, that means our 3 will change to a 4. So our answer would be 0.54. So one more time with this, anytime we take the natural log of base e, the answer is going to be the exponent. And again, the rationale is because the natural log is log base e. If the base of the log is the same as the base of the argument, then remember, the answer is just the exponent. So anytime you take the natural log of base e raised to any power, the answer is going to be the exponent.